Hi, welcome to the video for section 10.4. In the last section, we talked about multiplying and dividing radical expressions. And in this section, we're going to talk about adding and subtracting radical expressions. And we'll also look at some multiplying that gets mixed up together with adding and subtracting. Okay, first of all, true or false? The square root of 9 minus the square root of 4 equals the square root of 5. Well, let's work it out. What is the square root of 9? It's 3. What is the square root of 4? It's 2. What is 3 minus 2? 1. And is that the same as the square root of 5? No. The square root of 5 is not 1. So when it comes to subtraction, the order matters. If we take square roots first and then subtract, we get a different result from what we get if we subtract first and then take the square root. So unlike with multiplication and division, with addition and subtraction, the order matters. You can't interchange the order of the operation with the taking of roots. So the square root of one thing plus the square root of another is not the same as just the square root of the two numbers added together. The square root of one thing minus the square root of another is not the same as just the square root of the numbers subtracted. And same thing is true with other kinds of roots. You can't interchange adding and subtracting with taking cube roots or fourth roots or any kind of root. So be careful of that. So what if we have the square root of 45 minus the square root of 20? Remember, we can't first subtract 45 minus 20 and then take the square root. But there is something we can do. Remember how we talked about simplifying radicals? We can take the square root of 45 and break it up into the square root of 9 times 5, and then the square root of 9 is 3, and the square root of 5 is just the square root of 5. And we can do something like that with the square root of 20. 20 factors into 4 times 5, so the square root of 20 would be the square root of 4, which is 2, times the square root of 5, which is just the square root of 5. And now, the 3 times the square root of 5 minus 2 times the square root of 5 equals 1 times the square root of 5, or just the square root of 5. So the square root of 45 minus the square root of 20 is equal to the square root of 5. And I'll just point out that that's something that you can't really do on a calculator, but you can check on a calculator. If I asked my calculator for the square root of 45 minus the square root of 20, it tells me that that's 2.236067977. That's not what we want, but I can check with my calculator that that is the same number as the square root of 5. That's also 2.236067977. So the calculator doesn't tell me that the square root of 45 minus the square root of 20 equals the square root of 5, but it does tell me that those two things are equal to each other. So things like this you can't do on a calculator, but you can check them with a calculator. Okay, now in general, what's going on here is a lot like what's going on when you combine like terms. You should have learned long ago that if two terms that are being added or subtracted have the same variable part, that means the same variables to the same powers, we call those like terms or similar terms. And if they really are like terms, you can combine them by keeping the same variable part and then adding or subtracting the coefficients. So for example, 3x squared plus 5x squared combines to 8x squared. But 3x squared plus 5y squared cannot be combined. It has to just stay separate as 3x squared plus 5y squared. And 3x squared plus 5x cubed can't be combined because even though the variables are the same, they are to different powers. So a similar thing happens when you have radical expressions. If two terms that are being added or subtracted have the same radical part, we could say they are like radicals, and you can combine them by keeping that radical part, the part that involves a root, the same, and then just adding or subtracting the coefficients. So for example, 3 times the square root of 13 plus 5 times the square root of 13 can be combined into 8 times the square root of 13. The radical part, square root of 13, stays the same, and the coefficients, 3 plus 5, add up to 8. But if we had 3 times the square root of 13 plus 5 times the square root of 17, that can't be combined because the radical parts are not the same. And if we had 3 times the square root of 13 plus 5 times the cube root of 13, those can't be combined either because the square root of 13 and the cube root of 13 aren't the same. So for something like that, we have to just leave it the way it is. There's no way of simplifying that. So let's work through some examples. The directions are combine, that is, add or subtract, if possible. 9 times the square root of 7 plus 8 times the square root of 7. Yeah, we can combine those. The radical part is the same, so it adds up to 17 times the square root of 7. And next example is almost the same, except there's a minus sign in front of the 9. So negative 9 root 7 plus 8 root 7 equals, well, negative 9 plus 8 would be negative 1. So negative 9 root 7 plus 8 root 7 would be negative 1 root 7, or just negative square root of 7. How about negative 9 root 7 plus 5 root 2? Can't combine. Since the radical parts are not the same, we can't combine these, so it has to just stay the way it is. It can't be written any different or any simpler than negative 9 root 7 plus 5 root 2. Okay, how about negative 9 root 8 plus 5 root 2? Here again, the radical parts are different. They're not the same, so we can't combine these, at least not right now. But there is something we can do. Look at the square root of 8. We can take 8 and factor it into 4 times 2. And that's useful because 4 is a perfect square. So we can break up the square root of 4 times 2 into the square root of 4, which is 2, times the square root of 2, which has to stay just the square root of 2. And now we have negative 9 times 2, so that's negative 18, times the square root of 2, plus 5 times the square root of 2. So we have simplified the square root of 8 into 2 times the square root of 2. That's one of the things we were talking about last time. And now we've got negative 18 times the square root of 2 plus 5 times the square root of 2. And now these are like radicals, so they can be combined into negative 13 root 2. The negative 18 plus the positive 5 add up to negative 13. So the negative 18 root 2 plus the 5 root 2 combine to negative 13 root 2. Next example, 4 times the cube root of 2 plus 7 times the cube root of 2. Are these like radicals? Are the radical parts the same? Yes, they are. So we can combine these into 11 times the cube root of 2. The radical part stays the same, and the 4 plus the 7 add up to 11. Just like 4x plus 7x would equal 11x, 4 cube root of 2 plus 7 cube root of 2 equals 11 cube root of 2. How about 4 times the square root of 2 plus 7 times the cube root of 2? Are those like radicals? Can we combine those? No, we can't. It has to just stay the way it is. These can't be combined. What about the square root of x plus 5 times the square root of x? Are those like radicals? Are the radical parts the same? Yes, they are. So we can combine them into just one term that involves the square root of x. And what's the coefficient? 1 plus 5 gives us 6. So 1 times the square root of x plus 5 root x combine to give us 6 times the square root of x. How about the square root of 18 minus the square root of 8? Are the radical parts the same? No. Can the radical parts be simplified? Maybe. Let's check that out. 18 can be factored into 9 times 2, and 8 can be factored into 4 times 2. And that's useful because 9 and 4 are both perfect squares. So we can take the square root of 9 and get 3, and we can take the square root of 4 and get 2. So now we're looking at 3 times the square root of 2 minus 2 times the square root of 2. So now these are like radicals. 3 root 2 minus 2 root 2 equals 1 root 2, or just the square root of 2. How about this one? The square root of 500 minus the square root of 5. Are they like radicals? No. Can we simplify either one of them? Well, 500 can be factored into 100 times 5. So the square root of 100 is 10 times the square root of 5 is just square root of 5. And now we have 10 root 5 minus root 5, and that's equal to 9 root 5. Okay, what about this? 7 times the cube root of 11 over 3 minus 4 times the cube root of 11 over 2. Are the radical parts the same? Are these like radicals? Yes. These both have a radical part that is the cube root of 11. So they can be combined, but they are in fractional form and the denominators are not the same. Remember, to add or subtract fractions, we need a common denominator. So to get a common denominator, the lowest common denominator would be 6. So to turn these into expressions that have 6 as the denominator, I'd have to multiply the 3 times a 2, so multiply the first fraction by 2 on top and on the bottom, and multiply the second fraction by 3 on top and on the bottom. And when we do that, we get 14 times the cube root of 11 over 6 minus 12 times the cube root of 11 over 6. And now that they have the same denominator and the same radical part, we can combine them. The 14 minus 12 would be 2. The other parts stay the same, so this is 2 times the cube root of 11 over 6. And that can be reduced, the 2 on top over the 6 on the bottom, reduced to 1 over 3. So in lowest terms, it's just the cube root of 11 over 3. Okay, I'm going to stop this video right here, and then I'll come back for part 2 to talk about multiplying rational expressions. So see you in part 2.